Suppose you're given 0 to 1, x to 1 of e to the y squared dy dx. This integral cannot be calculated as it is because the integral of e to the y squared does not come out to be any of the function that we know, like sine, cosine, exponential, any trigs or anything. I mean, if you use some computer algebra system to find this out, it will give you the error function, but that's not something that we know about. So it cannot be integrated as it is. So once you know that it cannot be integrated as it is, and if the question is still asking to compute it, you should change the order of integration. In the exam, I'll be nice and say you'll need to change. I'll write this something like that. You will need to change the order of integration to calculate. Or sometimes people just write hint. Try changing the order of integration. So those hints may be given, but most likely it's something like that is given. Let's try to now change the order of integration. To change the order of integration, you have to draw the domain. Y equal to x and y equal to 1 should be drawn. Y equal to x is this. Everybody knows that. Y equal to 1 is here. And because it has dy means it's an increment in the y direction. What's increment in the y direction? That means you're going upwards. So you're starting at y equal to x and you're going upwards until you reach 1. And then your x value is from 0 to 1, so your x value starts from 0 and it ends at 1. So these paint brushes are doing its job with its beginning point at x equal to 0 and it ending at x equal to 1. It paints everything. And it ends up painting this triangular shape. Then changing the order of integration means that you're trying to paint the same region going right, just like this. And it begins from this end and it ends there, right? The paintbrushes, when you see where these paintbrushes begin, it starts here and ends there. Yes, you have a question?
Oh no, I didn't. I was wondering why was that triangle and not the opposite triangle, but I realized.
Oh, okay. All right. So you start from here, and you end there, and therefore you have to figure out the equation for this line here and also for this line. Okay. So what's the equation for this line? X equal to 0. It's a vertical line, therefore the equations should look like x equal to a number. How about this? Well, it's same as before. This is y equal to x, right? So you write down x equal to 1. See, if you have dx inside, when you write down the integrals, the values that you put here should be x equal to. So rather than writing y equal to x, you should write x equal to y. All right, so you have x equal to 0 as the starting point of the brushes, and x equal to y as the ending point of the brushes. E to the y squared, that's still the same, but dy dx is now changed to dx dy. And then what remains is the y values. So as you're painting, what's the minimum y value and what's the maximum y value? That's the question. What's the minimum y value? 0. And the highest y value is? 1. So it goes from 0 to 1. That's what we have to integrate now. And because we know that we did the change of order of integration correctly, we know that this integral is exactly the same as before. So if we can compute this, it's going to give you the value of what we were trying to compute. All right, let's do the integral. What's the integral of e to the y squared? Now, before it was impossible because we were trying to integrate by y. Now this is a very easy question because when you integrate by x, y is treated as a constant, right? And anyone can integrate a constant, right? What's the integral of the constant? What do you get? E to the y squared times x, okay? And then y 0. Okay. And remember, these are x equal to y and x equal to 0. So these endpoints should be plugged into x only. You don't plug these into y. It's x equal to y and x equal to 0. Okay, so y goes into x, creating e to the y squared times y. And then 0 goes into x, creating e to the y squared times 0, but that's just 0. That's why you have to integrate. Now, it looks like we still have to integrate this by y. And you might ask, what's the big deal? What's the difference between the previous one and this one? There is a big difference. The big difference is having this y. This y here will enable you to use a u substitution. So let's use a u substitution. Set u as y squared, which gives you du equals to 2y dy. And therefore, you can say 1/2 of du is y dy. Now, I just left the y dy. Why? Because y dy is right here. So y dy is now 1/2 du. That's what I find. And also, there's another thing. When y is 0, what's the value of u? 0 squared is 0. Okay? When y is 1, what's the value of u? 1. 1 squared is 1, so it's that. So, just by coincidence, you got the value of u as 0 and 1, which is the same as before, but in many cases, the values, these values are different, and you want to change that too, okay? All right, so you have e to the u, y squared is u, so e to the u, times 1/2 du, because it used to be y times dy, but we figured out that y dy is same as 1/2 du. The integral of this, 1/2 can be pulled outside because it's a constant multiple, so you only have to integrate e to the u. E to the u integrates to e to the u. And it's 1, 0 here. So when you plug in 1, you get e. When you plug in 0, you get e to the 0th power is 1. So that's it. That's the integral. Yes?
If you wanted to keep the y bounds, could you would just plug in y squared back?
Right. So I know that some of you were taught to not to change the bounds, but plug in the y back in there. So in that method, what you would do is you would write down y equal to 0, y equal to 1, either u 1/2 du in that place. Instead of this, you're going to write this. And then you integrate this and you get 1/2 e to the u just like before. But because the bounds that you have here are y values, you can't plug them in here. And therefore, you have to do one more step, which is to replace u by y squared, which is 1/2 e to the y squared. And then, since y is 1 and y is 0, these are y values. Now these can be plugged in there, and it will give you the same answer. So that's another approach, which I don't really like. I'm not a fan of it. I think it's better to change the bounds. In most cases, that gives you a quicker answer. And from what I have seen, I've seen most people messing up because they didn't change the bounds, but they didn't do this either. They just plug in those bound values into u, and they think that they got the right answer. And when trying to avoid that kind of mistake, it's better to use this approach. So that's why I like to promote this approach rather than the other one.